Hi everyone, how are you today? Okay, now let us enter a new chapter called Gravitation. Today, I just want to summarize a few things that we will learn in this chapter, Gravitation. Okay, in this chapter, we have three subtopics. The first one is called the gravitational force and gravitational field strength. And then we will learn, in 7.2, we will learn gravitational potential energy. In 7.3, we will learn about escape velocity, satellite motion, and also the speed of satellite and the period of satellite. Okay? Now, let us start with gravitational force. Right? Sometimes we call gravitational pull. Gravitational force or gravitational pull. They mean the same thing. Okay? So the formula is Fg equal to gmm over r square. So gravitational force, you must have two masses. You must have two masses, then only exists the attractive force between these two masses. You must have two masses, then only has gravitational force between them. They are called the point mass and the test mass. R is the distance from point mass to test mass. In detail, is actually from center of point mass to center of test mass. Okay, the unit of force is of course Newton, right? Next is the gravitational field strength. Gravitational field strength, also called acceleration due to gravity. They are the same thing. Okay? Now, you see, how to find gravitational field strength? Gravitational field strength is Ag, A or A, acceleration. Okay? Actually, this formula comes from this one. We learned before, weight equal to mg, isn't it? Mass times gravity. So this time, instead of we put weight, we put Fg. They are the same thing, gravitational force. Okay, weight is actually gravitational force. And then G, we put Ag. Because G is only the value 9.81. That is the G value 9.81 only exists on the surface of Earth. When you go away from the surface of Earth, go further and further away from the Earth, then the value is no longer 9.81, but it will become less than that, less than 9.81. That's why we put Ag. Okay, we put Ag. So W equal to mg is actually F equal to mag. So now the mass divide below. So we have Ag equal to force over test mass. This m is the test mass. All right. This m is the small m, the test mass. So F divided by test mass, or we can say gravitational field strength is actually force per unit mass, Newton per kilogram, force per unit mass. So when we divide this formula, gmm over r square, with the test mass, so the test mass gone, left with only point mass. So Ag, gravitational field strength, is actually equal to gm over r square. Gravitational field strength, or acceleration due to gravity, only has one mass, which is the point mass. Why point mass? Because it is a point mass that provides the gravitational field. It is the point mass. We use point mass. We don't use test mass. The point mass provides the gravitational field. You see, this one. This is the point mass. This point mass provides the gravitational field around it. You see? And this is the test mass. It is inside the gravitational field of the point mass. Okay? So, how to find the gravitational field strength experienced by the test mass? So the strength of this gravitational field, the strength of this gravitational field all depend on the point mass. The higher the point mass, the stronger the field around it, isn't it? The bigger the point mass, the stronger gravitational field around it. So this gravitational field strength depend on the size of the point mass who provide the gravitational field. That's why we use the point mass, not the test mass. Okay? This test mass is inside the field of the point mass. So the gravitational field strength it experience depend on the point mass. So this is the point mass. Okay, enough of that. Now, how about this R? R is distance of point mass to test mass. Okay, so it has a radius of Earth plus altitude. If the test mass is not in the air, if it is on the surface, then it's just the radius of Earth. But if it is in the air, then don't forget to add to plus the height from the surface, or called altitude. Height from the surface means altitude, right? So this R is radius of Earth plus altitude. Don't forget you have square. Okay. Now you see, these tools, force and field strength or acceleration due to gravity, they are called vectors. They are vector. So they have direction, and when you do questions, don't forget to put arrow because they have magnitude and direction. All right. All right. Just now, back to this one. The force is Newton. Good. Field strength is also called acceleration due to gravity. So AG has two usable unit. You can use Newton per kilogram or also meter per second square. Both unit can be used. But if the question asks for field strength, then you use the unit Newton per kilogram. If the question asks for acceleration, then you use meter per second square. So depend on context. Okay? Good. Now, let us go to gravitational potential energy. Gravitational potential energy, the formula is U equal to negative GMM over R. GMM over R. So potential energy also depend on two masses. You must have two masses, then only has gravitational potential energy on the test mass. Okay, you must have two masses. And you must have a negative sign. The negative sign is very, very important. Okay, and it is a scalar quantity. It has no direction, no arrow. Okay, unit is joule. Now, let us look at what is meant by this gravitational potential energy. Why this time we have negative? Okay, look like that. Yeah. The maximum potential energy in our context is at R infinity, which is 0 joule. 0 joule means it is free from gravitational force or gravitational pull. You see like that. At the surface, the potential energy is considered to be most negative. Most negative. I just put a value there, negative 10,000 joule. As it go higher and higher, the potential energy become less and less negative. In mathematics, when we think of a value less and less negative, the potential energy is actually getting bigger and bigger. When a value become less and less negative, means the value increases, isn't it? So same thing, the potential energy, as it go higher and higher, become less and less negative, approaching 0. So become less and less negative means the potential energy actually increases with height. Okay? Potential energy increases when you go up. So potential energy maximum at 0. Maximum at 0. 0 means it is free from the gravitational force. Means the planet no longer pull on the test mass. Yeah, the planet no longer pull on the object. Yeah, it doesn't experience any gravitational force anymore. That is potential energy equal to 0. It's considered the highest. When at the surface is most negative means potential energy is lowest. Lowest is most negative, highest is 0. Remember that. And then this escape velocity, now we will go to that. Okay, now escape velocity. What is meant by escape velocity? Escape velocity is when you are at the surface of a certain planet, you want to escape from the gravitational pull, like what you see here. the object is on the surface. You want to escape from the gravitational force or gravitational pull. You want to go from most negative from the surface to the infinity distance where u equal to 0. You want to go from most negative to become u equal to 0. The velocity you need, you need to jump with escape velocity in order to achieve this. You need to jump with a velocity which is we call escape velocity to provide you the enough kinetic energy to convert to potential energy. Okay, so that's called escape velocity, to jump from most negative to become u0 from the surface. Remember, so escape velocity is you want to escape from the surface. You start from the surface. Remember, you start from the surface. You jump with escape velocity, then until you become u equal to 0, until you over here, you reach here u max u equal to 0. Okay, from here go to here. At here you are free from gravitational force or gravitational pull. That's called escape velocity. To calculate escape velocity, this formula, square root 2 gm over radius. Okay, this mass is using the mass of the planet because you want to escape from this planet, isn't it? So the bigger this planet, the bigger mass of this planet, the higher escape velocity you need. For example, if you compare between Mars, a small planet, with a Jupiter, which one easier to escape? Which one easier to escape? Of course, the Mars. Which one is harder to escape? The Jupiter. The Jupiter has a very big mass, so you require a very high escape velocity. Okay? So this escape velocity, we use mass of the planet. The bigger the mass of the planet, the higher escape velocity required. Now also depend on the, this R is using radius of planet. Remember, it's radius of planet. Why you use radius of planet? Because you escape from the surface. You escape from the surface, so the distance between the surface to the center is the radius of the planet. Okay? From surface to the center of planet is the radius of planet. So this one use radius of planet, remember. Now, lastly, we learn about satellite. Satellite motion, it travel in the orbit. Okay, it travel in the orbit. So it has a speed. The satellite has a speed in the orbit. Okay, actually this back to the concept of chapter circular motion, where the gravitational force provide the centripetal force. Okay, gravitational force provide the centripetal force. From this formula, we get another formula for speed of satellite and also the period of satellite. These two formula actually come from this formula, Fg equal to Fc, gravitational force equal to centripetal force. Okay, now where is the satellite? Where is the satellite? This is our satellite. Okay, this is our satellite. Now, satellite is in the orbit. This is called the orbit. So to find the speed of satellite, tangential speed of satellite, we use square root gm over r. Okay, the mass here, the mass is of course the mass of Earth. This is the Earth. Okay, and the mass, use the mass of Earth, and r is the radius of the orbit. It's the radius of orbit. So remember, it's not the radius of the Earth only, but it's actually the radius of the orbit. Because we are talking about satellite in the orbit. So to find this r, radius of orbit, it is radius of Earth, because this radius of orbit is, the center of Earth. The center of Earth is actually the center of the orbit. They share the same center. So the center of the Earth is the center of the orbit. So we can say that the radius, we can write as From here to here, this is the radius of the orbit. So what is the radius of orbit? Radius of Earth plus the altitude. So these are, the R here and the R here is actually radius of Earth plus the altitude. This is the, H is called the altitude. Alright, good. Remember, this mass is the mass of Earth, not the mass of satellite. Don't go to use the mass of satellite. Use the mass of Earth. Alright. Period of satellite. Period of satellite is 2 pi square root r cubed over gm. So this is also mass of Earth, and this r also radius of orbit. Radius of orbit means radius of Earth plus altitude. We can say that period. What is mean by period? Period means the time taken to complete one circle, to complete one revolution. So we can say the bigger the radius, if the bigger the orbit, the longer time period needed. I mean, it takes longer time for the satellite to complete one oscillation if the orbit is bigger. Okay, so R increase, period increase. Remember that. Now, one thing I want to emphasize here, you see, escape velocity and speed of satellite, they almost have the same formula. Escape velocity is square root 2 gm over r. But speed of satellite is only square root gm over r without the 2. But they have different meaning. Escape velocity is any object want to escape from the surface. So you want to escape from the surface, the r below here, just use radius of planet. Just use radius of planet. No altitude. No altitude. Okay? No plus h. But the speed of satellite, these are, we know satellite is not on the surface. Satellite is in the orbit. So high up in the sky. So it is radius of the orbit is actually radius of Earth plus another altitude. This one you need to plus another altitude. Not like the escape velocity, only the radius of planet. For speed of satellite, this radius, you need to take the radius of the planet plus the altitude. Because satellite is not on the surface, it's in the orbit, high up in the sky. Escape velocity, you start from the surface. So that's the difference between escape velocity and speed of satellite in terms of their r. This r is only the radius of planet. This r is radius of planet plus altitude. Okay? So I hope you enjoy today's lesson, and following videos, we are going to discuss several questions on gravitation, how to solve them. Yeah, we have what? We have gravitational force, we have gravitational field strength, gravitational potential energy, escape velocity, speed of satellite, and period of satellite. All these will be covered in the video tutorials. So I hope you stay tuned for the upcoming videos. Please like and subscribe. Bye.